Hello everyone. In this video, we are continuing class 12 chemistry coordination compounds. Under that, we are doing valence bond theory, octahedral complex. In the previous video, we have already done an example for octahedral complexes. That is structure of octahedral complexes on the basis of valence bond theory. The example that we did was hexamine cobalt 3 ion complex. If you have not watched that video, please click the I button in order to watch that so that you understand this video better. We were also able to explain the magnetic property of that complex. It was a diamagnetic ion complex. In the formation of that complex, the inner d orbitals, 3d orbitals, are involved in hybridization. Therefore, the complex is called inner orbital or low spin or spin paired complexes. In this video, we are going to see another example, structure or formation of hexaflurocobaltate anion complex. The charge on this complex is 3 negative. In this case also, cobalt is the central atom. There are 6 fluoride ions attached to it. Hence, it is octahedral. We will see the orbital picture of cobalt atom. The atomic number of cobalt is 27. Argon 18. 3d 7. 4s 2. This is the orbital picture of cobalt atom. In this complex, cobalt has a charge of 3 plus. So we have to show the orbital picture of cobalt 3 plus ion. Cobalt has become 3 plus ion means it has lost 3 electrons. 2 of the 4 s electrons and 1 electron from 3d. Atomic number of cobalt 3 plus ion also is 27. It is now short by 3 electrons, that's all. Here there are only 24 electrons. You can count and see. In this complex, 6 fluoride ions are attached to the central cobalt atom. Fluoride ion is a weak ligand. So, the pairing energy is not sufficient. Therefore, the fluoride ion cannot pair with the single electrons in the 3d orbital. In order to accommodate 6 fluoride ions, hybridization takes place and 6 degenerate orbitals are newly formed. The type of hybridization is sp3d2 hybridization. Hybridization takes place in the central metal atom. The single 4s orbital, the 3, 4p orbital and 2 of the 4d outer orbital get hybridized to form 6 hybridized orbitals. That is what I have shown there, and 3 of the d orbitals remain separate. The orbital picture of cobalt 3 plus ion now becomes like this. There are the 6 hybridized orbitals and 3 of the 4d orbitals not participating in the hybridization shown separately. Now we are approaching 6 fluoride ions donate 1 electron pair each to these hybridized orbitals. Now this forms hexafluorocobaltate ion. Now it has 3 negative charges. Let us see how it gets 3 negative charges. The central atom or the central metal ion has received 6 electrons additionally from the 6 fluoride ions. You may say there are 12 electrons received. I will explain. In each pair of electrons received from the fluoride ion, 1 electron belongs to the fluorine atom. The other electron in each pair is the electron which is additionally received by the fluorine atom to form the fluoride ion. We need consider only those electrons. Cobalt has 3 positive charges on it. So it requires 3 electrons. So 3 of the 6 electrons on the 6 fluoride ions get cancelled there. 3 electrons only remain. So the complex develops 3 negative charges. So from this you can understand that when this anion forms a compound, coordination compound, it can receive a cation with 3 charges or 3 cations with single charge each. We are not going into those details. Now before we conclude this video, please note from the orbital picture of this hexafluorocobalt 3 minus ion that it has 4 unpaired electrons in its 3d orbital, that is in the inner d orbital. So we can predict the magnetic property of this complex as paramagnetic. Since it is the outer d orbital, that is 4d orbital, which takes part in hybridization, this complex is called outer orbital or high spin or spin free complexes. We will meet in the next video with another important topic like this. Till then, take care. Bye. Thank you.